and good morning or good afternoon or good evening to everybody. Thank you so much for joining us today. Welcome to all for this International Women in Engineering Day, organised by the World Technology Universities Network and hosted by the University of Bradford in collaboration with Asia Technology Universities Network, or ATUNet for short. My name is Denise and I am the WTUN Development Manager and organiser of today's event. We have a fantastic lineup of speakers joining us today from the UK, Bahrain, Thailand, Malaysia and Indonesia, all here to celebrate women in engineering and offer their expert perspectives on subjects related to the overall theme of INWED, of making safety seen. Before I hand over to today's hosts, Dr. Elaine Brown and Christina Tuina-Bobe, I would like to thank Asia Technological Universities Network for their collaboration with the World Technology Universities Network today. As a fellow alliance of technology-focused universities, we share a commitment to collaboration and knowledge sharing for the benefit of all. Some housekeeping: we ask that you remain muted throughout and use the Q&A function to ask questions to our speakers. Today's session will have several opportunities to ask questions for discussion, and I'll be here in the background monitoring the chat and taking questions. So please allow me to introduce our hosts and chairs for today's session. We're joined by Dr. Elaine Brown, who is a Reader and Associate Dean for Equality, Diversity and Inclusion at the University of Bradford. And Dr. Christina Tuina-Bobe is the Research Knowledge Transfer Business Development Manager, quite a mouthful, based at the University of Bradford, also in the Faculty of Engineering Informatics. Thank you both for hosting and moderating today's session. Elaine, I'm going to hand over to you.
Thank you, Denise, and welcome everybody. It's an absolute pleasure to meet you all today and for you all to join us at this webinar. I'm just going to say a little bit about the day and the event and introduce myself, and then Christina will introduce herself, and then we will go on to hearing from our fantastic panelists. So, Women in Engineering Day began in the UK in 2014. It was a national campaign from the Women's Engineering Society as part of their 95th anniversary. And it received UNESCO patronage in 2016 and became International Women in Engineering Day. The role of engineers is to solve technical problems for the benefit of society, and to do that effectively requires the ever-changing needs of people, all people, to be fully understood and met. For this, we need a greater diversity in engineering teams. In the UK and in many other parts of the world, women are underrepresented in engineering careers, but we know that visibility of positive role models will encourage more girls and young women to enter the profession. So how fantastic that we've got so many wonderful examples here today. International Women Engineering Day is a really wonderful opportunity to celebrate technical achievements of women and to provide those role models. At the University of Bradford, our EDI strategy includes work to understand and close gender gaps, so opportunities to influence and inspire young women are embraced, and this is why we are delighted to mark this day. So my name is Elaine Brown. I am a mechanical engineer working at the University of Bradford, as Denise said, and I am so happy to be here. I'm just going to pass over to Christina, who will also introduce herself before we get on with the technical parts of the day.
Hello, nice to see you all. I'm so excited about this event. I am an engineer. My background is in biomed, and I'm proud to be an engineer that traveled a bit around Europe and so on. I've been in different countries and met exciting people. My role at the moment is to promote our research and to make a difference to industry, to governments. So that's where I am at the moment, and I look forward to hear your presentations.
Thank you, Christina. So in session one, we have three fantastic women talking about their area of expertise and their research. Looking at the information that's been provided in the abstracts, I could group it into a broad theme of our environment, but looking at very different aspects of our environment, the interactions and the influences that affect career choice. So the human environment, how people speak to us from when we are very young, or the influences that we see, and that comes into play in affecting this gender imbalance that we have in engineering. the human factors in our physical environment, where we live, where we work, where we move around, the important things that we need to think about to make sure that we are comfortable and safe. And then the personal and privacy safety factors in our online environment, which is now so important, just as it's our physical environment, and thinking about how we need to think about our personal safety in that aspect as well. So the 3 talks will take place, and please do put your questions in the Q&A box during those talks, and we will pick them up in a short Q&A at the end of the session. And then, of course, we have a general Q&A after all 3 sessions. So the first speaker that I'm going to introduce is Dr. Nariman Intarat, who is from Thaksin University in Thailand. Thank you.
Thank you. Could I share my screen? Hello, good evening from Thailand. Could you see my screen, right?
We can see it clearly.
Yes, thank you so much. And first, want to say good evening again. I'm Dr. Nariman Intarat, lecturer of mechanical engineering from engineering faculty of Thaksin University, Thailand. Today, I'm really grateful to this chance for being one speaker in the international women engineering. Today I'm going to talk about human factor infection, women engineering. At first, I want to say that don't judge everything they are, even they one are carbon-based like carbon. So now I'm going to talk about the human factor. I want to give meaning of the human factor. What is the human factor? Human factors are concerned with the understanding and managing the capability and reputation of people. So I want to say that everyone can fall an error in the everyone can make error and matter how well training and motivate they are. Sometimes we are set up by the system to fail. So the challenge is to develop error tolerance system and prevent error from occurring. So I want to say that clearly we can change the human condition, but we can design activity, plan, process, and the procedure is such a way taken into the account human infection. So now I'm going to say about the human factor. What it include in the human factor? Human factor include in the work factor, people factor, and organization factor. You know, for the work factor also include in the equipment. We need good equipment for work. Also, disturbance, it means we no need to more disrupt for the work in the offline for the job, any job, and also instruction. We need sure and clearly for instruction for worker, for the minute everything for the work, for the job. And another is maintain. We need the good maintain. If we have a less maintain, we've got the not good result for this work. And another is the workload. It means if we get over workload, also will affect with the work, with the result of this work, with any position for work, maybe impact for staff will be tired, will be bored like this. And another is the working condition. For working condition is also important factor. If we have an unhealthy, unsafe for the condition, unclean for condition for working, it also cannot get the good result for this work. And the next factor is the people factor. For this factor include in the skill. It means if we staff have a low skill for that job, for this position, we also cannot get the good result for that job. Another is try or if staff have worried about this work, that their position, it also will make actually effect for the result. And another one is health. It means healthy is important factor. If staff have the healthy, it will can manage every job, every work is become too good. If unhealthy, also will impact in the job. And another is organization factor. It means the organization factor must have the organization must have the good training for the staff, for the worker, must have the safety system for them, must have the comfortable system for safety, for reduce the accident in the work, in the organization. And another is management. Organization must have the good management for all staff. And another is, I want to say that human factors are about ensuring a good fit between people, the equipment they use, the tech they carry out, and the environment in which they work. Effective use of human factor will make work safer, healthier, and more productive. And now I'm going to talk about what are human factor approaches. For the what
Doctor, sorry.
Yes.
Sorry to interrupt. We cannot see your slides advancing. I think you might have to put them onto presenter view. We still can just see the first slide.
Sorry. And let me check.
Now we can see slide number 6.
1, 2, 3, 6. Yes, now you see number 6, right?
Can you try just moving forward and backward just to see if we can see them as you progress through?
Now you can see when I'm sharing my slide.
No, it's just it's a static image. They're not moving with you. If you quick at the bottom of the screen, if you go into presenter view, we might be able to see them when you move.
Can I show like this? Now you can see my screen on.
Yeah, we can see that moving.
But when I show like this, you can't see. Sorry, now you can see on us.
Yeah, we can see it. I'm just not sure if we're going to be able to see it if when you're clicking through. So if you change slide, could we just check?
Now in slide for the what are human factor approaches? Did you see?
We can just see the don't judge everyone as they are, even diamonds are carbon based. It was the slide number 2, I think we can see now.
Sorry. Oh, okay. Then I think I need to share like this. And now it's changed.
Now we can see what are human factors approaches. Yeah.
Okay.
Sorry to interrupt.
No, thank you. Thank you so much. Okay, sorry for my. Okay, and now I'm going continue for talk about what are human factor approaches. At first, it identify the characteristic of people who will be working in the system or using the product. And second, it identify the requirement of work to be undertaken. And last one, it evaluates the nature of work, a system, or the products. Now I'm changing slide. Did everyone see my next slide? Sorry.
We can still see the other slide.
Okay, I think that's so. I need to change one by one. Okay,
yeah, I think so. We can see that, yeah.
Okay, sorry. So now I'm going to say about the engineer pathway for women. So that's why when women are being engineer, we are common influence factor is the female participate in the section of the engineer pathway, including the parent influence, teacher influence, self-efficacy, perception, and attitude. Next is the gender stereotype, and the next is the peer and media influence. This is the influence for the engineer pathway for women. As for the parent, most parents believe that their boy have more activity and size concept more than girl. That is how they treat son and daughter are different. They will give some toy or some activity for men or for boy or for girl. It's different, you know. And in the teacher influence also the same. The teacher will have the belief it's same with like a parent. They also thinking a man, the boy have a performance more than the girl in some activity and some interests. So teacher negative evaluation of the girl ability can even overlook their actual good performance and become their belief. This is the problem for the girl, for the woman. And then self-efficacy, perception, and attitude. If girls do not think positive about their own mathematical activity, it will affect their later achievement. For the girl, even they perform it well, but they still thinking that they are not good enough. This is the problem for the girl, thinking that it may be the follow from the parents and teacher influence. And for the gender stereotype is the even thought in the recent time they are lost of the explicit statement about the equality of the boy and girl, but still have many people still unchanged. They still unconscious believe that the boy they will have the more perform than the girl in some activity, in some interest like this. And the last one is peer and media influence. For the, it means for the friend and media will affect for the girl attitude. It means if the girl have the friend, they did not believe about the girl can do engineering, girl can lie in the science and the math. They also thinking the same with the friend allowed. And also for media, you know, in nowadays, not nowadays, for almost in many years, for the media in the movie or story, they almost show the engineer is the male, not female. That is why the female did not thinking being engineering in the future. This have infection for girl attitude and belief in stronger influence their career decisions. So I want to say that whatever you want to do, is no matter what you are, you can do. It's not matter you are girl or boy, you can do everything what you want to do. And next I'm going to talk about the factor women face when they study engineering. I know almost everyone here, we are engineers. We are studying for engineering faculty before. So, you know, when we enter in university, environmental, there are disadvantages due to the gender inequality. For the example, social influence, it means maybe it's because the including in the culture. Also, because culture are different and next is the part experience. This is the follow from the parents and teacher. How parents and teacher treat us when we were young. Maybe some parents will treat the man, treat the boy in the some activity support for the math, for the science, but did not do for the girl, for their daughter. This is the problem. And next is a female own perception. And when women being engineering, women be in engineering, women disadvantage in this fight, it include attribute. Next is organization culture. It's the same. You know, for organizational culture, it depends on the almost people who living in the organization now is the boy more than the girl. So the male more than the female is mean that they will have the culture is different. They also will treat the male more than the female like that, and also the work environmental maybe is not met with the girl. Girl maybe the sensitive with something, but the boy is different. That is the problem. And
1 minute remaining, please, Doctor. 1 minute remaining.
Also, okay. For women who affect in high standard for activity than men, this is the high pressure for the girl. So I want to say that, however, in split there are factors that women are facing. Some women actually succeed. I know everyone here, we are women, we also succeed like a boy. So I want to say that I think women can actually stand out in engineering. Women can be as some male. They are also stand out because they are sensitive to different in the culture and bring a different perspective to problem solving and decision making. Okay, it's finished. Thank you so much. Dr. Nalamon Intrat from Thaksin University, Thailand.
Thank you so much. A lot of food
Thank
for
you so
thought
much.
there. Thank you.
Thank
And
you.
actually, we will move on to questions at the end of the session, but it just reminded me, hearing your presentation, that there is another reason for events like this, and that is to support each other as well, because how important is that? We will move on to our second speaker, please. So this is Dr. May Al-Safar from Aliyah University in Bahrain. Doctor, are you able to share your screen?
Oh yeah, is it being shared now?
Yes, but we can see it in a similar mode to in the previous presentation. If you're,
so I'm just trying to do it on. Yeah, now I think it will be good.
Yes, that's very clear. Thank you.
Okay, thank you very much for this opportunity, and I would like to introduce myself. This is May Al-Safar. I'm an architect and academic at the same time. I worked like several years in architecture, and I was struggling with all of these men around me. But by the end of the day, we stand up for our rights. And today I'm teaching males and females at the same time, which make me proud of myself to share my knowledge with my students and with you people. So my talk is going to be a continuation to the human factors, but how can we use it in design? And how can we create a comfortable and safe built environment as part of the theme that we have in the Women International Day? So this is our journey. We'll have like a quick definition. I'm not going to repeat what my colleague, Dr. Norman stated. We will have more of a better fit between us and the environment, and then within the archiette, which is mainly the architecture and interior design, and how can we go universal, and finally towards a comfortable and safety environment. So at the beginning, I would just highlight the main factors of human, which is going to be the physical, emotional, cognitive, social, and cultural. So in reality, any environment will have an interaction because of the man, because of the environment, and because of the machine itself. So all of these factors are going to affect how we are going to represent ourselves as a woman and as a man, of course, because we are trying to call for equity between genders. So we are going to talk about all the users of the space. So we have interaction between these factors on us as humans, but these are going to affect our behavior, and this behavior is going to affect how we perceive these spaces. So generally, we are trying to avoid any accidents within these interactions within our interior spaces. So if we move to a better fit between the environment, so we will see that the human factors will create more of a combination between organizational, technological, individual, and in the environment itself. So let's start with the technology, which is now a main component in our lives. For example, appliances, equipments, or even our screens. These screens are trying to create ease of our life, trying to reduce any error that may happen to us in our spaces. For example, whenever you are looking at your screen, which is your mobile, it's going to create more of a reduction of time. Okay, it will save your time, and at the same time, it's going to reduce the effort for you. So this is the first one. While on the organization, we as women, we are going through different types of pressures. Okay, so for me as an architect, when I was at a younger age, I used to go out, for example, on the sites, okay, and check the work with my colleagues from the male gender. But nowadays, the demands are different. So we are trying to depend on technology to create this better fit with the environment. Then when we move to the, I'm not looking at the screen, okay. When we are moving to the environment, So the environment itself has the noise, has vibration, maybe temperature, maybe pressure. All of these are going to affect how do we interact within our environment. Finally, it will be the individual perception and experience. Our experience will define how we interact with the environment. For example, a perception of different ages, different cultures, different genders are always going to affect how we fit ourselves within the environment. So in the field of architecture and interior design, which I name it ArchIED, when we look at architecture and interior design, both of them are the creation of an environment or the creation of an experience. So our main focus is going to be how this conceptual stage or conceptual design of this entire space is going to connect me between inside and outside. And at the same time, it will affect the people. So we are now going to the psychology of design and how can this space affect our performance and create a better space for us. So as humans, we are different, okay, because of our experience, age, culture, and even cognitive levels. So some people will have like a direct plans for things, some people will have like a dynamic plans, and some are going to be for a complicated plan. But at the same time, we are always trying to achieve safety in our spaces. So the safety is always first. And whenever we design, whenever we practice, whenever we perform any type of task in our spaces. So as you know, we have general design considerations, which are part of the universal design. So as a diverse, okay, so we have equitable use. So we want to have equal usage of these spaces from all different people with different capabilities. The second one is going to be about the flexibility of this space and how can we define it or change the layout or spatial layout of this space to suit our performances as well as to accommodate different tasks that we wish to do within our spaces. While the intuitive, it's mainly to keep this space easy for the people. So regardless of your language, regardless of your age or race or even culture, we want the space to be communicative with the people. We have in architecture something called the architecture language. So we want the place to communicate with the people. And regarding the perspective, so we want to create a communication within the space, which is necessary to communicate the information that we wish to pass to the people in a very easy way. And usually we use signages and symbols. The minimum hazard, which is mainly what we are looking for in, as part of the theme of the Wtun this year. So the design should minimize all of these hazards, and I'm going to mention some of the strategies that we as a designers need to implement in our spaces. Then we have the low effort. As I mentioned earlier about the screen and how it will create a low effort for us. Again, the door handles, for example, how they are created, the washroom, how is it designed? So everything is going to create this type of low effort for us. Even the sensors during the COVID-19, we went for this contactless in everything. Okay, so this is going to reduce the hazard, and at the same time, it's going to lower the effort. And finally, the appropriate space. How can we create spaces which are accommodating different nature of people and also numbers of people? So the body and the ergonomics, as well as the posture, the body, excuse me. Yeah. As well as the posture of the body will define how our spaces look like. So towards a comfortable and...
So just giving you the one minute notice.
Sure. So towards the comfort and safety, we have smooth leveling of the flooring between inside and outside. So we usually suggest that we never go for like one flight. We want to go for a lower flights. Why? Because just to reduce the pressure on people. Then we need to widen our hallways and corridors just to accommodate people with different abilities. And finally, in this slide, we have about how can we create products that are suitable for left-handed people because they are suffering. And I don't know if any one of you left-handed here. Then we have how can we equip the technology in our spaces, okay? And it is mainly to communicate with all senses. Then we have the tactile flooring and contrast between materials. And finally is how to use lighting as indicative materials. Thank you very much. And that's it. Thank you very much.
Thank you very much, Doctor. Another really good example of why we need diverse people to work in engineering so that all of these things can be recognised and designed into the system. So that's wonderful. Thank you. And please do, for all the people watching and listening, please do come through with your questions. We have one more presentation in this session before we take some questions. So I'd now like to invite Professor Mahendrawati from ITS in Indonesia. Professor, are you able to share your screen?
I think the previous speaker needs to stop screen sharing.
Sharing. Yeah, stop share. Okay, just so it. Okay. Thank you.
Thank you. All right. Yes, can you see my screen?
Yes, not yet in presentation view.
Okay. Yes.
Perfect. Thank you.
Can you see now?
Yes.
Thank you very much, and thank you for inviting me to be part of this International Women in Engineering Day. My name is Mahendrawati, and I am from Information Systems Department of Institut Teknologi 10 November in Surabaya, Indonesia. My background is actually an engineer. My first degree is in industrial engineering, and I carried on to do my master and PhD degree also in industrial engineering, but somehow I get into information systems department. So now I will talk more about the intersection between my background in industrial engineering and where I work now in information systems department. My talk is the key role of people and process in ensuring workplace safety and security. So the outline of my speak would be about I will give a little bit of background because we are from a very diverse domain and area. And then I will talk about the problem and then focusing more about the people process before I close the session. So information systems, I think all of us now actually, without knowing, probably already using some kind of information systems. This event is made possible because of the advance of information technology. So an information system is a unique configuration of IT resources and organizational processes whereby the IT resources and the information they provided are applied to support specific organizational processes. So IT resources include software, hardware, and also network and, for example, any aspect of technology that provide you with information. Now, most of us are thinking of using information system, but information system is usually used for organizational processes. So now we will move on what we think about process. So here I will talk more about workplace processes. So it's more, the term is business process. What is a business process? A business process is a series of interrelated events, activities, and decisions which involve several actors and resources and together produce outputs that are of value to the organizations and its customers. So I will talk more about how at work, people are actually working together to do something that of value for the customers or the organization itself. Now, I'm a professor in business process management. So this is more about a discipline that involves how you model, how you made it automate and execute, control and measure the flow of these business activities in appropriate combinations to support enterprise objectives. And it spans across organizational and system boundaries. So it engages employees, customers, and partners within and beyond the enterprise boundary. Now, the IT in workplace, so information technology in the workplace now, I think almost every aspect of human is already interfered with IT. So we work together, we are using computer and we are connected to the internet, and many IT is used in the workplace. But what I'm mostly interested now is the possibilities created by millions of connected people with mobile devices, which have unprecedented processing power and storage capability and access to knowledge. These are limitless because now everybody is using mobile phone to get connected. Now, this in one aspect created a lot of opportunities, but it also creates a lot of threat, be it a safety and also security threats. So what are the problems? First, safety and security for organizations, especially private organizations, are often considered to be secondary to other objectives. So most organizations will focus on profit, on value, but sometimes they neglect the security and safety. At the same time, people are also are sometimes lack. They are not aware of the safety and security threats when they are using information technology. And finally, there are lack of rules and enforcement to ensure that the people are using all the safety and security standard to do their job or their individual day-to-day lives. So this is a quote that I took from an IT security researcher. They said that he said business managers are not interested in IT security and tend to pay lip service to it because IT security is seen as an expense that brings little tangible benefit. So IT security obliges employee to spend time and money on activities that considered add no value. For example, in information systems, sometimes we have when we pay for something, we created an account. So it is supposed to be attached to the person itself that pay for the account. But sometimes when organizations want to save their funding, they share the account. So in that sense, they're actually not attached to a person, but for several persons. So when there's something happen, it is difficult to trace who is doing what. So the accountability is less. And also sometimes we tend to use, or organizations tend to use unsafe or insecure systems just because it is free, or it is something that they considered easier to use, but less safe or less secure. And again, I repeat that there is no safety and security measure because sometimes people think that, oh, they already know, then we don't need to put any safety and security measure anymore. So those are the problems. Now, how can we try to make this like the theme of today is how to we encourage people to see that security and safety are important. We know that now a person has a digital mindset because they are using information technology. They become consumer, they become producer. Like every day, sometimes now we can see that every ordinary people creating content that they post on their website or they post on their social media account. So they're also producing content. And at the same time, they are part of the community and they are also taking part of many activities related to the business. So we need to make these people aware that they need to consider the process that they are part of. So this is what the Thomas Neubauer is proposing. So organizations need also to put economics valuation of security. They cannot ignore that safety and security is something important. So when they try to make a decision, they should consider as well that safety and security is something that they need to be invested on. Now I will move on more to talk about how we use social media, because social media is changing the business. For example, now from selling, usually before company only sell to their customer, but with social media, they can connect with the audience, not just selling, but also trying to understand what the customer wants. And the customer is also freely giving feedback, be it positive or negative. So from giving a large campaigns, now organizations can reach to one small or specific individual to connect and sell their product. From controlling the message to transparency. Now the problem is sometimes everything is so out there. Something that is personal can also be made public because everybody try to make themselves seen.
Just giving you
Now,
1 notice, Professor.
Okay, thank you. So this is an example that a company can do. For example, when customer posts about fair trade, so the organization need to have a protocol to respond to what a customer is saying. So the person that is in charge with the social media understand how they need to react. This is an example also of a company putting a rule and regulation about a comment or posting that a client is doing. So we can say, we can evaluate if this posting is actually factual. If yes, then we try to post back or reply. But if it's just a troll or this site is not or ridiculing or degrading, then we need to do something else instead of trying to also get involved with something that can also produce something worse rather than solving the problem. So in summary, because the limited time that we have, I think the final words for us, all of us, as someone that is involved in IT or using IT, is that we have to be mindful. IT can be useful, but it also poses a lot of threats. But organization also needs to have a clear process of what they need to do with their IT and put in a lot of safe and secure rules to ensure that the people are safe. I think that's all from me. Thank you very much.
Thank you very much, Professor. 3 fantastic and very thought-provoking presentations there. We have about 5 minutes for questions. I'd just like to ask a question first of all, maybe to each panelist, but we'll see how we go with time. So it relates to the entire theme of the day, really, but in particular to that first presentation around the factors that can affect girls and boys from a young age and what effect that then has on whether they choose engineering. So maybe I'll go back first of all to Dr. Nariman and say, when did you first decide that you wanted to be an engineer, and did anybody put you off, and how did that feel?
Thank you. For me, it's easy to say that boy and girl, we are equal because I must to say further, I'm not engineering, but I'm professor in engineering. I'm already take class for the engineering for master degree, bachelor degree, and doctor degree. All is engineering for master and bachelor, and the mechanical engineering, but in the doctor degree and in power and energy engineering. But in Thailand, we are for my culture in Thailand, we are same, we are equal, boy and girl. But you know, when I'm going to another country for PhD and study in the China, I am living with the foreigner student. I live in and I'm a last one for the female engineering. They did not believe that I can study engineering. And when I'm graduate, I'm wear the suit in a doctor degree. They also say, wow, how you get it? How is women can study engineering? How you can do engineering? And also how you can do PhD degree? Because they did not believe that the girl can do. You know, some culture is different. They already just at this woman it weak, woman is no have the performance like this, that. But then I can say that if we believe in self, we have parents, we have any support from friends, we can do everything. So that's why today I forgot to talk about the women factor for women in engineering. So that's why I think we can do, and women equal with the men. We is not matter what we are. That I think. Thank you.
Thank you. It's certainly something that I think many people here on this webinar have in common. Maybe Dr. May, do you have any examples from your own experience?
Yeah, actually for me, my father encouraged me to study architecture. Okay, and at the beginning, I just, I was enrolled in civil engineering. And after that, I felt that it's not my area. I'm more of an architecture. And then throughout my life, while I'm a student, I faced some issues because of the mathematics and so on. So one of my relatives just say, well, I don't think engineering is good for women. You should get out and learn, and I will say it as it is, learn how to wear makeup. And it hurted me a lot. And I took it as a challenge in life. He said, you should like fix your hair and do makeup. And these are the things that are related more to women than engineering. And I'm not seeing you going out, like running from side to side with your father. And I was like, really? And it hurts me a lot. And after that, I start challenging myself. And I studied in architecture, and I graduated with high grades of GPA of 3.5. Well, I was at the beginning facing some issues. And after that, I worked as an engineer. And then I got the opportunity to do my postgrads, the studies in Germany, the Bauhaus Foundation. And now I'm a doctor. Okay, so I went like through different phases in architecture, starting from pure architecture to urban design, to green and environmental studies. And finally, my PhD was in history and theories of architecture. So I finished all of the different parts in architecture. I'm very proud of myself and very happy to share my story with you people today. And it should be encouraging for all ladies in life. There is no boundaries. You can do it if you want. You just dream big and try to do it in a realistic way. This is my advice.
Thank you. And I think for reasons of time, we will have to move on to the second session, but maybe we can come back to some of these stories later on at the end. And it just goes to show, I think, that sometimes when people challenge us, it has the opposite effect. It actually emboldens us and encourages us to push forward. So that's also very good advice to young women who are considering technical careers. So with that, I'm just going to draw this first session to a close, but there is no gap in our webinar. We are moving directly on to our second fantastic session. I will just pass over now to Christina.
Thank you, Elaine. Our second session of this event comprises work in the area of biomedical engineering. We will hear about cell-based therapy technologies and from Maria about antimicrobial technologies for orthopedics. These technologies do not only advance the science, but make a difference for people. They alleviate, they improve quality of life. So a very important area of research we will unpick here. Our first presentation is coming from Thailand. Dr. Kwan Viravadia Paswat from KMUTT will give us the first presentation. Please share your screen. Thank you.
Okay. All right. Thank you, Christina. Let me share my presentation. Okay, I believe that you can see my presentation now. Okay,
Yes.
all right. Good evening to the audience in Asia, and also good afternoon to audience in the UK. My name is Kwan Chanok, but I usually go for short as Kwan. I'm from King Mongkut's University of Technology, Thonburi, Thailand. My background is in chemical engineering, but I have done a lot of work in biomedical engineering, particularly in tissue engineering. So what we're going to be talking today is the cell-based technology that we have developed in our research group and how we are using an automated cell processing system to help our work to proceed into a clinical study. So before we start, I would like to give you an overview of cell-based therapy because it may be like a name that may not be very familiar to everybody. Cell-based therapy is basically using cells in order to treat diseases that you have seen. So we hope for a better treatment this way. So we start from having tissues from patients and then isolate the cells, culture the cells, create into tissue, and then put that back into the patient. And our work is basically focusing on cell isolation, expansion, and also tissue engineering part. So we have a strong collaboration with doctors from medical school. We got samples from medical school doctors. So I'm going to give you one example of our project that we have done is to make tissue engineered cartilage. So we get cartilage sample, we isolate the cells, which are chondrocytes, the cells that are responsible for the strength of the knee. But of course, when you get cells from these tissue, they're not enough. So what we do is we need to expand it into large enough quantities so that we can put it back. And we use technology called temperature responsive polymer, which is the polymer that responds to different temperature. So at 37 degrees Celsius, the polymer becomes hydrophobic, so cells can attach and grow very well into a monolayer. But when you reduce temperature to about 20 degrees Celsius, the surface changes from hydrophobic to hydrophilic, so it pushes out the cells into a sheet. But one sheet is probably not enough for the treatment. What we do is we stack those sheets together to make it into a thick piece of tissue. And we characterize this tissue by looking at collagen type 2. So you may have heard that if you want strong knee, you need to have collagen type 2. So we stain cells with collagen type 2. So you see these green color to indicate that we do have good tissue engineered cartilage. And to prove that this is safe and also effective, we then transplant that into a rabbit. So we're using a xenogenic model, which means that we use human cells in a rabbit animal. And it turns out that in about 12 weeks, we can see that it goes from holes into cartilage that's filled with tissue. So we believe that this has potential, and we definitely want to move forward into a clinical study. But what we have found is that using cartilage samples may not be desirable. The reason is because you need two surgical procedures, one to get the samples out, and the other is to put the tissue back into the patient. So that's why we explore different options, which is to use mesenchymal stem cells. So these are stem cells that can be changed into different cell types, depending on the chemicals that you use to direct those cells. So our idea is to get bone marrow from patients, then isolate stem cells, expand them, and construct that into pellet. So pellet, these are about a millimeter small cells that we have characterized already that, okay, it contains collagen type 2. So we know that this is a good cartilage tissue, and then transplant that back into animal to test for safety and efficacy. And we have found that this is actually a pretty good method because if you look at the video clip, you can see that you try to squeeze this tissue, but it still stays. So it actually strong enough that can withstand the force. So imagine that if you put that into patient in the knee where it has a lot of load, it should stay. We also create another model, which is osteochondral construct, which indicate that it has cartilage at the top, bone scaffold at the bottom. So this is for the treatment that has pretty deep defects. And although cartilage has to be strong, it's not exactly cartilage tissue just yet, but you can see that it stays. When you press it down, it does not break out or anything. So it should survive the transplantation in animal, and also in the future for clinical study, it should be able to be possible. So we again test the safety and therapeutic potential of this treatment. So comparing between the top part, which is the one without transplantation of tissue, bottom is the transplantation of stem cells. You can see that we still have holes here, but this cartilage completely filled with tissue that we want. So we believe that, okay, this is definitely possible, and we definitely want to move forward to clinical study. However, we found that there are some challenges that we need to address before we can move into clinical study. First of all, we have different researchers, different techniques, and you can see that we have different outcome of the tissue. So we want to find a method that can consistently make the tissue that similar. Also in Thailand, it's hot and humid, so we have a lot of visitors from bacteria and fungus, and that is probably not a good thing for you to put in your body. So the top part is the lab that you have seen typically for tissue engineering, not very clean, but you cannot do that with clinical study. You want something with GMP compliance to make sure that it has the best safety protocol, so the product is safe enough for you to put into human. So that's why we introduced an automated system. Automated system is a robotic arm that is housed inside isolator. Isolator is basically clean room class A. So it's very clean. You can periodically sterilize, so you can ensure that the system is clean, that the product is also clean. And I want to move forward so you can see the system that we have. We have actually 2 robotic arms that can move just like human. The machine itself is something that we purchased, but what we develop is a software inside that control the movement of robotic arms using the protocol of cell culture that we have designed. All right, so you can see that we can do everything here. Our researchers can be outside and control everything through a computer. And this way, we don't have to have human intervention to the process. And we can ensure that is no contamination and its aseptic environment can be confirmed. And we also compare the performance of our robot system with the researchers, and we see that they are comparable. So this can solve a problem with shortage of trained personnel or trained researchers, because like researchers can come and go, but the process has to go on. So we can not replacing, but we can have trained researchers doing something more important than routine cell culture. And in order to comply with the rules from Thai FDA, we are in the process of building a clean room so that the isolator can be here. This design has already been approved for the Thai FDA, and we hope that the construction will be finished within a few months. And we hope to get a license approval for cell production in about a year. Okay, thank you. And here is our goal eventually, that we want to set up a facility that we can provide cell for different hospitals that really want to do clinical research, but these hospitals do not have facility to make cell processing. So we can push forward the regenerative medicine industry in Thailand that way. And all this work is not possible without our team. So we have a strong support from the team, from our researchers, postdoc, PhD students, master students. So these team are the one that help our project to move forward. And last but not least, I would like to thank the funding from Thai government through Thailand Center of Excellence in in Life Science, and also our university that see the potential of this project and put in a lot of funding for us so that eventually we can do translational research in the future. And that brings to the end of my talk. Thank you for your attention. And I'll be happy to answer any questions towards the end of the Q&A session. Thank you.
Thank you very much for this amazing presentation and for sharing with us your work. Our second presentation is coming from our very own Dr. Maria Katsikogianni, University of Bradford. Maria, the screen is yours.
Thank you very much. Hello, everyone. It's a great pleasure being here today. And I'll just share my screen. Because I can't really see my slides. The one I try to share. There we go. No. Okay. I hope you can see them now. Potentially, I will move. Because see. Just give me a second. I cannot find that. So hopefully it is in screen sharing mode now. Yeah.
Now, yes. Thank you.
Perfect. So today I would like to tell you a little bit about our approaches in order to develop materials that either prevent bacterial adhesion and therefore infections associated with medical devices, or even if we can treat some of those. So it is around the safety aspect of things. And just to say a few things, that there is a clinical need, because when we start thinking about orthopedics and when we think about potentially a knee replacement or a hip replacement, the infection rates can be quite low. However, when we talk about trauma, and especially about this kind of pins that are used to stabilize fractures that cross through the skin, then the risk of infection can be quite high. And it leads to either failures or non-uniform fractures and chronic osteomyelitis. A number of bacteria are involved, especially Staphylococcus is the most common when we talk about orthopedic infections. And in order to design our approaches, we try to understand a little bit what happens with the bacteria when they see the surface. So essentially they start attaching, they form what we call a biofilm. It's like a community. And I think when we realize that there is an infection, people use antibiotics in order to try and tackle this problem, but we feel that it is a little bit too late. So we actually try to design surfaces that could actually treat this first step. So can we stop bacteria from attaching to surfaces? I think it will be easier to deal with this problem at that stage rather than when they have established their communities. So try to understand a little bit about the parameters that affect bacterial adhesion. Actually, there are many, but here in Bradford, we work in two areas. So one is to use surfaces that they have what we call the non-fouling capabilities. So having a kind of a topography that potentially will stop bacteria from sticking down, or they release an antimicrobial, or combining the two approaches together, as I'll show you in a bit. Now, I think when we discuss about orthopedics, people think about metals, but here in Bradford, we're quite strong in the area of polymers, polymer chemistry and polymer processing. So we start thinking about PDMS, or polydimethylsiloxane, for small joints. Also biodegradable polymers, mainly for fixation kind of applications when people have either sutures or for a fixator after a fracture, or even thinking about PEEK, that nowadays is used for knee kind of replacement. Potentially you have heard about the all polymer knee. So for the first project, and in collaboration with the University of Cardiff, we started changing the chemistry of PDMS by adding some triclosan, a kind of broad spectrum antimicrobial. And we combined this with a kind of change in the topography approach with Professor Ben Whiteside in the engineering, where using compression molding, we designed surfaces that look like that, and we created PDMS that rather than being kind of flat, they have this kind of pattern. We call it the butterfly wing kind of pattern because of this grooves. But when we add a lot of triclosan, you see that we are not able to reproduce well this pattern. And what we realized then was, with a nice replication of the pattern, we can actually see nicely that there are less bacteria. So if you see the PDMS pattern, but when we have this kind of very high surface area topography for the 10% patterned PDMS, then you see that we have dead bacteria. You see they're red, so they're dead, but they're still too many. And we're a bit skeptical about this, thinking that potentially it will stop the material being integrated with the human body if bacteria find the opportunity to go there, even if they are dead. So we prefer approaches where we have a nice pattern and we stop bacterial adhesion. And we follow this similar concept when we used PEEK. And we saw that actually the pattern, so you see the red dots down there, reduce significantly bacterial adhesion in comparison to the flat, even after 1 hour. And you see that after 24 hours, in the case of the flat, we have an established biofilm, but not in the case of the pattern, so that you see far less bacteria and certainly not a biofilm as in the case of the flat. Now, thinking about knee replacements, for example, people think, well, can this actually integrate with the human body? So we did some cell work and we found, well, actually, the cells actually like it. So although bacteria don't really like it because these small grooves don't allow a good cell adhesion, we found that eukaryotic cells are quite large and they actually like this kind of grooved surfaces. And the last topic I would like to present today is this, it was a collaboration with the University of Sheffield where we used biodegradable polymers this time. So if you think about suture materials, all kinds of fixators for bone fractures, and we added into those bioglass or strontium bioglass. Strontium is quite famous for promoting bone growth and regeneration. And we added in that mixture cerium nitrate, either with the glass, the bioglass, or the strontium one. And what we found, so essentially using again engineering capabilities regarding mixing polymers with other compounds and then giving them the shape using molding. And we actually found that the presence of cerium nitrate or bioglass or the combination of strontium bioglass and cerium nitrate did not really affect cell viability, which is a great thing. And then when we did our bacterial adhesion studies, we found, as you can see on the right-hand side, when we add cerium nitrate, you see far less bacteria in comparison to the polymer itself. And when we did fluorescence imaging and live dead staining, so the green is a live bacteria, the red is dead, we see far less bacteria in the case of cerium nitrate, and they are actually mainly dead in comparison to the polymer with the strontium bioglass. So you can see how the addition of cerium nitrate has actually helped us to reduce bacterial adhesion and viability in this particular case. Now, taking this forward and combining this with patterning, I think will be our next step. So just to summarize, coming from a safety point of view and bringing using technology to solve real world challenges, I think is very nice to be able to say, well, we can actually help as engineers to design surfaces that either inhibit bacterial adhesion and growth, or whether we can actually kill them if we try, let's say, to treat an established infection, and then how engineering approaches can be used together with chemical approaches in order to having the right combination of a pattern and an antimicrobial that can lead to some useful applications. So I presented here the medical side of things. Potentially you can think about applications in the area of food packaging or environmental kind of applications. I would like to conclude this talk by thanking all the collaborations. You see a lot of people from the University of Bradford, mainly Professor Ben Whiteside, who is active in the area of injection molding, and all my colleagues in Bradford, but also from the University of Cardiff and the University of Sheffield, and obviously our funders. And thank you very much for your attention. It's been a pleasure being here today.
Thank you very much, Maria, for sharing with us your work. We had a question in the chat, but Dr. Viravaidya already answered to that. I would like, the question is for both of you. How difficult do you find to work at this interface in between biomedical, engineering, chemistry. For example, I'm a biomedical engineer, and one of my colleagues told me, "Oh, did you choose this area because it's easier because there are more females in it?" Actually, I find it more difficult than ever because it is not true, first of all, and secondly, you need to bring knowledge from different areas.
Yeah, I think I had that same challenges because people thought that the reason I want to do research in this area because it's easier comparing to like other engineering aspect. But yeah, in reality, it's not, because you need to apply engineering to and use biology fundamental as well, which are very difficult, both of them. So it's just, for me, I think it's more fun to do biology with engineering. It gives us like bring engineering knowledge in order to apply to biology and biology to engineering. So it gives us like broader view of what we need to work on.
Thank you.
In my case, my father wanted me to be a pharmacist and be in Greece on a small island and run a pharmacy practice. Now, in my case, I do enjoy the medical side of things. So potentially this was one of the reasons I'm really interested in what cells and bacteria do. So potentially I think that's why I came into this discipline. When I went to the engineering and I did all these years of PhD, then my father said, "Oh my God, you would have been a doctor after all these years." So you see, the medical aspect of things is always there. But I very much enjoy seeing technology being applied and using technology and communicating with the others. And you need to communicate with the doctors and you need to understand their problems in the clinic. So I very much enjoy being at this interface.
Do you find the weight on your shoulders, because the technologies that you are developing needs to be used into humans and needs to have that positive impact, and is the pressure as well of so many people that are suffering and you want to alleviate that empathy kind of side of things. Do you feel a weight on your shoulders, and do you find like that sometimes work takes over life, and in your case?
Oh, definitely. I feel that we are not moving fast enough, because we want to use this product in human. There are a lot of safety concerns that we need to answer, and it takes a long time. I always got questions that when will I be able to move to clinical studies so that we can actually see the potential and see that it's being useful in human. I just have to tell them that you have to wait, because we are trying to build like solid foundation in order to make sure that it's safe for everybody before we proceed further. So yeah, it's frustrating, but we are trying.
Christina, I feel the weight is there, definitely. But at the same time, if you compare this to a doctor that they need to make decisions quite fast and act and all this kind of thing, I think we are in a kind of a safer environment where we do have the time. I mean, I do appreciate that it takes time, and I would have liked our, problem solving to be seen in the clinic faster. But at the same time, we do have the processes in place for the safe transition to the clinic.
Thank you very much to both of you. And now we will move to Elaine Brown again, to Dr. Elaine Brown for session 3.
Thank you, Christina. And yeah, I've been writing lots of notes and ideas down as everybody's been talking today. It's fantastic. So in session 3, again, we're moving to a different aspect to think about. So it's so nice to see that in our webinar today, we're, as well as representing gender diversity, we've also got huge diversity in the expertise and the areas of research of all of our speakers. So in session 3, we've got 2 speakers who are both experts in wastewater treatment and hazardous waste management. And this is an area that, interestingly, I was at another event recently where 2 of our young alumni from Bradford were both also working in this area. And they made a really impassioned pitch as to why this area needs more engineers. Water, access to clean water is a fundamental need for human safety and by extension for the planet. We need to have clean water and we need this for the safety and security of our planet. So it's really great now that we can hear from our two speakers around their innovative solutions to ensure safety and hazard control through education and industrial settings. So our first speaker in session 3 is Dr. Nur Hayati Abdullah from UTM, Malaysia. Yati, are you able to share your screen? Perfect. That's great. Thank you very much.
Thank you, Elaine, for the kind introduction. Good evening, ladies and gentlemen from Kuala Lumpur, Malaysia. I'm very happy to represent Asia Technological Network, ATUNet, University Technology Malaysia. And today I'll be talking about pivoting innovative solutions. Just a little bit of comments on the role of women wastewater engineers for making safety seen. So as we know, wastewater is part of the closed loop of water sector, and it's very interesting for me to be involved in wastewater engineering elements as part of it, because we find that working as a wastewater engineer is not a sexy job for women. It's dirty, it's smelly, and then we had to do some wastewater sampling, being in the wastewater treatment plant. Of course, with the word waste, it doesn't make it any more interesting or appealing for women to be indulging in wastewater engineering sector. So how I met wastewater, when I first decided to do my first degree with University Technology Malaysia, one of the top universities in Malaysia for engineering, I actually decided to do something else. Actually, it was psychology, but being a science student that time, and I have dedicated for about 5 years doing science stream. So obviously when we applied to university in Malaysia, we were more inclined to receive offer for doing engineering studies. So I began as a civil engineering, a bachelor in civil engineering at UTM back in 2002, and then proceeded to master in environmental engineering, and then PhD in biosciences, focusing on industrial wastewater treatment, treating the palm oil mill effluent from 2009 until 2012. And as I began to explore the importance of wastewater engineering, wastewater treatment, as to how might we produce clean water coming from all the processes that involved in producing wastewater, just being at home, as to how might we use water on a daily basis for every activities and programs that we do, be it at school, be it at home. I began to realize that, yes, wastewater engineering is an interesting field of research, and we can make it sexy, even though it's dirty and it's smelly. So life is like a sewer. What you get out of it depends on what you put into it. So I'll delve more into this quote later on the next slide. And being a wastewater engineering student, I had the opportunity to present my work, for example, at the SET for Britain competition at the House of Commons in London. And then I began to be exposed to mentoring with male engineers who are actually expert in wastewater engineering throughout my years as a PhD student. And then, of course, I had the opportunity, and I'm blessed really to be able to study at UTM at the Faculty of Civil Engineering. As you can see, we have 12 faculties, and University Technology Malaysia is really a focus niche area on various engineering studies and topics. So I'm very happy to be amongst the, I'd say 26,000 over engineering students, and being a postgraduate student also with UTM, starting my study as an undergraduate many years ago, about maybe 20 years ago, and then coming back to Malaysia and serving at my university is really a blessing and a great opportunity. Thus far, I have produced many more women engineers under my wings, under my supervision for PhD, and it's really a a proud moment for me to be able to teach wastewater engineering, as well as to introduce wastewater engineering as part of the curriculum study in UTM. Being able to introduce the interesting part as to how might we contribute to wastewater treatment, and as to how might we can improve wastewater treatment facilities in Malaysia for the betterment of water sector is really a blessing. So why we choose engineering, or why I choose engineering? As we know, women represent half of the world's population, and being in engineering sector, we may be able to help inspiring change. And knowing that we could perform the work of engineers, which is a male-dominated area of studies, and we are open to vast professional network and career development. This include mentoring as well as sponsoring. Mentoring can come from male engineers as well, and sponsoring by other women engineers who are more senior in the field. And we are open also to wider academic opportunities and appointments at various universities and industries worldwide. So this is something that I told my students to keep on, improving in terms of widening as well as exploring what women can do in wastewater engineering, despite it not being an interesting area of work or area of studies at all among women these days. In Malaysia, there are nearly 6,000 public sewage treatment plants and nearly 2,400 private plants. Poor management of private and public STP could result in uncontrolled pollution. So reuse of byproducts may mitigate this issue. And the three key byproducts are clean water coming from the effluent, biosolids coming from the sludge, and as well as methane gas released by wastewater treatment processes. So knowing these valuable value-added products coming from wastewater treatment plant is something that I never expected, because almost 95% of water that enters the home goes down the drain daily. And so what do we do with those water that finally becomes wastewater at the end of the daily activities that we do? We talk about wastewater closed loop. For example, rainwater coming from nature becomes stormwater management, and then we have to manage the stormwater in order to collect the rainwater in drains and reservoir. In Malaysia, this is not much happening, as to we are only beginning to provide rainwater harvesting facilities for new buildings or green buildings and new development of projects in Malaysia. This is important because most commonly stormwater becomes runoff water, and the water just is not being collected properly, and we are not actually using the water for any purposes. So basically this water just go down to waste. And then of course this water is treated to become potable water, to which we use at homes or industry. So it becomes here for industry usage or domestic usage. From the industry and domestic usage, those water becomes wastewater. So huge portion, 95% that I mentioned just now, becomes wastewater. What we do with the wastewater is to collect those used water in sewers, and then it goes to the treatment plants for used wastewater. It can either go to the sea, released to the sea as treated water, and then desalinate to become also to be used as industry in domestic areas, or it can also be recycled to be used as direct non-potable use for gardening, watering plants, etc., etc. So wastewater closed loop in Malaysia is very important, because we receive plenty of rain in Malaysia yearly. However, most of the rainwater is not harvested, and most of the wastewater that is being produced is not being recycled. So these are the two key things that our country is actually focusing, and university researchers is trying to translate as much knowledge as we can to the industry to benefit the community in terms of reusing wastewater. And then I had the opportunity to lead a ministerial project on COVID-19. This is like 2 years back when we were facing the outbreak of the pandemic. And then what do we do with controlling the coronavirus whether or not the COVID-19 can be detected in wastewater. So based on our scenario, the protocol is not very clear during that time. So it's very important for us to check on the localized sewerage zones, whether or not we can develop a fully effective control of spreading of the coronavirus during that time. Obviously, in our group, there were male engineers, but we have 2 female engineers and myself as wastewater engineering coming from UTM, working with our microbiologists to check on the wastewater, taking samples. So all of these is very important aspects of doing wastewater engineering. And we have to also, of course, making the safety being seen, taking all the necessary countermeasures to avoid being infected during the peak time of the coronavirus. So what we did was variant determination using next generation sequencing, to which I learned a lot from my colleague from the NGO as to how might we look into the microbes that we have inside the wastewater samples that we have, whether or not it poses any threats on coronavirus. And of course, just for me to talk a little bit about my PhD projects years ago, to which I continued on until today, a work on aerobic granulation for complex wastewater treatment, to which in Malaysia, it is being used by the National Wastewater Company to look into treating industrial wastewater coming to the plant. So we use biological approach whereby the bacteria form aerobic granular sludge, contributing to physical, chemical, and biological condition of the granulation processes should be, which is considered to be very important in wastewater treatment. And then, of course, being an engineer, communication is key. This is an article written by some newspaper about my involvement in wastewater treatment a couple of years ago. So engineers tend to be very hardcore. We focus on the technical aspects and the jargon, but sometimes we forgot how community, how normal people, layman words will react to it. So having an interest in psychology, to which the first area of study that I would like to venture upon after high school helps me to communicate my research to others. And I am able to make people understand that it is useful and beneficial for the community while maintaining the economy of whichever industrial wastewater area that we are studying and looking at. Therefore, these days in Malaysia, it is no longer appropriate to consider treated wastewater as a waste that requires disposal, but rather as resource that can be put to beneficial usage in accordance to the closed loop of the wastewater. And treated effluent should also be made suitable as it is economical for augmenting traditional water supplies in Malaysia. So thank you very much, ladies and gentlemen, for your attention. And if I may, I would like to invite everybody to UTM as we are having another Innovating Solutions and Expanding Horizon conference at UTM University President's Forum. And I would like to wish everybody a happy International Women in Engineering Day. Thank you very much.
Thank you very much, Hetty. And it's now time to introduce our final technical speaker of the day, and then we'll come to some questions. So I'd now like to introduce Dr. Netnapit Tentampasapia from Thailand. Doctor, can you share your screen? Right. So, yes, okay, I can hear you now, and we can also see your screen. Thank you.
Okay.
Thank you.
Hi. I don't know, good evening or good morning. Because in Thailand time is 7 p.m. at night, and we have a meeting worldwide. So it feels very good that I can talk and see everybody like all over the world from the webinar today and for the International Women in Engineering Day. Today my talk is about the safety, occupational health and safety for academic and school in Thailand. It involves my work that I've been doing for like almost 20 years in Thailand on occupational health and safety. I'm from Suranari University of Technology, which now we have 3 speakers. Today we have 3 speakers in Thailand and also in other countries. I'm very happy to join and share my experience. For the occupational health, safety and health in Thailand, we have law and regulation like the act that control everything. It's more like saying that all employees provide and keep establishment and in safe and hygiene workplace for all employees, which is the common law in every country, right? I think that probably we all have this kind of law. However, and in this act, they cover many things. For example, the fire hazard, chemical, electricity, and construction work, including like radioactive and working in the chemical laboratories. For this law is enforced workplace that have more than 50 employees and many types of workplace like my producing like factory, constructing, transportation, gas station, department store, hospital, and so on. And also cover a chemical or biological laboratory. So like when we working in the laboratory, we should comply with the law. However, in this regulation, it's not cover like all the activity areas, it's not cover school or university. So we can say the other word that like law and regulation are not applied for school and university in Thailand. So we have like 160 university, like 1.9 million students nationwide, and the school we have like 30,000 school with 6.6 million students, which means that there are so many things relating, like we have so many activities in school and so many risks relating in school. However, we don't have law or regulation or like a regulator but authority to taking care of the safety in school and academic, like in the university. So, and there are so many risks and there are no safety management guideline or like what to do into school, that the safety management, including safety policy, and like we should have committee and conduct OSHA training, and we should have like the accident notification going until emergency evacuation plan. I believe that in country like UK or like in European country or US, like the school and university has to do the safety management like is required by law, but in Thailand we don't have that, you know. So we have in 2010, right, we have OSHA in workplace law and regulation apply. However, in academic institute we don't have it, and most of staff in school are not aware of the health and safety, and their lack of health and safety knowledge, and administrator like a dean, president, and they don't concern about safety, that but they never heard of it, you know. In like about 15-16 years ago, nobody in Thailand concerned about it. So we formed groups of like working group, like from the university staff working together to team up and working bottom up. First, we start like networking with 10 major universities, and we trying to do things like making by little and little patiently. At that time, we lucky that we have a woman from USA. She's working in health and safety, and she came to Thailand. She is Thai though, but she's a professor in the USA. And she thinking that she should come back to Thailand and helps us to establish the safety in university and school. So she came here and educate us and created us together and making a team, and she started training. So I'm one of the team that start working with her at the beginning. And we working with small projects first and with the small group, with the small network. We're trying to talk to the dean and the president to have the safety issue established, but not many successful at that time. So we do little by little. And after that, in 2006, I did some little projects. So like all of us have little project of our own. And in many universities, so we're working with a network and sharing knowledge and start by little. So I work in waste management in laboratory, and I I built COD waste stabilization reactor, which is patented, and I did a chemical inventory program to do the waste management. And after that, like we've been doing this for almost 10 years. And after 10 years, the top people start to see what we're doing, and they start to think like we should have some establishment of health and safety in Thailand. So we start with National Research Council of Thailand, or NRCT. They launched the program to do the safety, but only in chemical laboratory, stating that like for the people who want to apply for the grant, you have to do the laboratory registration and pass the requirement. And also from the place where Dr. Wtun came from, King Mongkut, is the first university. It's also our network, and the university like start ahead above other universities. So the first one, because at that time the president agreed to do it first, so it's coming quicker than other universities. And so we have the system where we're doing the check for laboratory safety, and we establish the system by the system established by NRCT, and asking other university to comply to working on it. And they have like online course, like the researcher who want to do the laboratory has to do the test and pass the test. There are some manuals and some training on that. And in year 2020 to 2023, now we start, the NRCT start to expand to school. So they ask us to work as a node, training node for other university staff, making it like a trainer for high school students. So we are training node. We train other university staff, and other university staff train the high school staff. So it's coming like this. So they have like the manual, and also we have like the training material, like a video for kids, and some kind of train the trainer things going on. And 2023 now, up to now, the Office of Higher Education Commission, actually they have like a criteria, like a KPI for all the university. Like if you want to apply for the criteria to curriculum, we have to pass the criteria and like a KPI for all school. In this criteria, there is one item is saying that the personnel in the university should have a good working environment. So from this criteria, just about 2 years ago, that is just started. So the university has to pass this criteria for environment. So we start talking about health and safety for environment, for workplace in university. But still, now we still don't have this is the health and safety that we're doing in Suranali University, that we start establishing the safety committee, and we start doing risk analysis, and we enforce all the faculty member to do the laboratory training. And so now we have OSHA apply in some part, and also in the university we have hospital. So hospital is required by law, but in the university it's not required. So we have hospital in our university that have safety management, but in the university we don't have which is very funny. And we have in
Just
some
one-
faculty.
Just 1 minute
And-
remaining, Doctor.
Okay, and actually, so from in the past up to now, we have done so many things, like we have done developed occupational health and safety in academic and school, and we still growing, and like we start little by little and coming at like bigger and bigger. Now we still have no law and regulation guideline, but I can see the trend, like more and more awareness on health and safety in school, and especially after the COVID-19 epidemic. They have like emergency preparedness for COVID-19 in many schools, and also they have like a fire training and things like that in many schools. So that is the present. And in my point of view as a woman engineering working in the field, so I think like for me as a woman working here, we don't have problem like issue in Thailand. And for the health and safety issue, I think like most of my team are women and LGBT. So I think like for us in this field is we are very comfortable, because working like in safety field, we are more blend and can talk to people easily than men. I mean, like in my point of view, like some of the work women can work better than men, like, and most of my work, like we have to do little by little and like keep going until we achieve the goal. It cannot like be done and you can see the result immediately. So it has to be patient. Thank you for your listening. And I'm happy to share my experience with you.
Thank you very much, Doctor. So I'll just talk through a couple of questions. Oh, I can see a hand has raised. I'll just ask a couple of questions first of all around that session, and then we'll move on to some more general questions, if that's okay. Actually, I was just thinking about the presentation that you've just given. Were there any challenges to the work that you were doing? So by bringing in the health and safety requirements, did some people actually say that they weren't interested, maybe because it would take too much time or because it would be too expensive, or were you able to proceed as you planned?
There are lots of difficulties. First of all, for the top-down people, they have to be agreed to work with it. If the president are not agree, I mean, like, or the governmental officer doesn't have law and regulation saying that you need the school and university have to do it, it's very, very hard to go with that. And for people, you know, we have to be very patient, and we have to start telling them like it's your health and your concern, and you know, it's like working with the safety, you know, it's difficult by itself, because you have to convince the people to concern about their own safety, and they don't willing to do it because it's out of their way of lifestyle.
So an interesting point. Sometimes the need to bring it to a very personal issue can be something that's very persuasive then, isn't it? And it's really interesting listening to the differences in different countries, as you were talking about the laws and regulations. And yeah, you mentioned in UK we do have laws that cover universities as well. So I hadn't appreciated the challenges that you would be facing. So that's really interesting. I also have a question, if that's okay for Yati. It was around communication. You talked about communication of engineering, and also the fact that your area is dirty, it's smelly, this type of maybe not so attractive type of engineering at first. What kind of tricks and what kind of messages do you use to try to make this maybe more attractive to young women as well? What psychology do you bring in?
Thank you, Elaine. I did spend a couple of months studying environmental psychology. And we had a discussion because I used to work with International Water Association, the IWA, as an NGO. So we had a discussion as to how important it is to involve social scientists into translating the knowledge of engineering to benefit community. So let's say if we have a breakdown in wastewater treatment plant, it's a matter of urgency as to making sure that we need to get back on track in terms of the treatment of wastewater, making sure that this will not impact the health of human beings or a society that is connected to the system. But it's very difficult sometimes to make the public understand the urge or the importance to focus on wastewater treatment. So people may see that they want to have clean water at the end when they open the tap, and then clean water flows out, and then they can use water straight away. What public do not understand is that those water will eventually turn and become into wastewater at the end of the processes, the daily processes or daily activities that we do. What public don't understand is that what happened to those wastewater and the importance of having it being properly treated so that it will not impact the health and well-being of community, animals and plants and human beings. So in this regard, we women engineers, we do not have the capacity as to how might we translate the knowledge or how might we best communicate engineering importance to the public. So this is an ongoing discussion that we normally have. And for me personally, when I indulge into wastewater engineering, I began to see the importance of it. And when I began to understand the closed loop wastewater treatment, how water cycle relates to wastewater engineering and wastewater treatment, I began to see the importance of it. And whenever I see calamities that is coming from wastewater treatment, in Malaysia, for example, we have either drought or excessive flood. So when flood happens, for example, you can't use the toilet because the cistern is full and the tank is full and things like that. So it becomes super dirty and somebody has to take care of those dirts. So I feel really blessed and proud to be part of the wastewater engineering, segments. Not many women are working within the wastewater engineering sector. Yeah. So, and the ability to combine wastewater engineering with water sector is another different kind of opportunity to explore. So I get to see both the importance of both water and wastewater sector and how they complement each other. Thank you.
Thank you. No, it's really interesting. I think that we tell our undergraduate engineers at the University of Bradford, we tell them that communication of what they're doing is as important as the work that they're doing as well. And it is something that's really important. So it's just interesting about the bringing in social scientists as well. I don't know if panelists might be interested to know something that actually myself and Maria and Christina have been involved with recently, was something that was funded by the Royal Academy of Engineering in the UK, where we have been working with a theatre group, and that was to develop a show actually for children between the ages of 6 and 11 to help them to understand engineering. And children of that age love to think about what goes down the toilet and what happens to it. So actually we did focus quite a lot on the wastewater. And that show was taken to a science festival, Cheltenham Science Festival, very recently. So yeah, lots of fun to do. And for me, it taught me a lot about communicating as well. So many things that we need to think about as engineers. So that's the end of the session 3. We do have some time now for general questions to all of the panelists. I think we've got a few minutes left. I've noticed that there are some questions in the chat. I don't know if we want to actually voice those questions as well. Denise, is that something that would be helpful?
Our panelists have been very diligent in responding to the questions. I know that one of our attendees did have the hand raised, so perhaps we'll go to Wipui to ask the question live. I'll just allow her to speak if she wants to ask her question, but please, if anyone wants to put up a message in the chat or put their hand up, I think our panelists are still here, ready and willing. So I'll hand over to Wipui to ask a question.
Hello.
Hi, Wipui. Welcome.
Hello. Hi. Hello. Thank you for the opportunity for me to speak. Actually, I just wanted to ask each our delegates with if they had any challenges in communicating, convincing clients or colleagues or even the public related to the work they do from a women's standpoint, and what were their ways to overcome those challenges. So yeah, thank you. This could be to any participant who would like to share their experience. Thank you.
Would any of our panelists like to take that question first? Let me just see. Okay. Nobody is
Maybe
Maria is offering to answer first, I think.
Yeah, I can give it a go. So if I understand it well, it's like if we had any challenges trying to communicate what we do with either the public or colleagues. I mean, what I find sometimes is that it is about colleagues actually, and it is interesting that they see us as female, and they think that oh, the admin is something that female either do better, or potentially they sometimes feel a little bit too important to deal with that. So the challenge I face sometimes at work is that it comes my way a little bit more admin that I would have.
Oh, I think Maria has. Oh, no, there we go.
Sorry, I think it's my connection here.
Yeah, it's okay.
Is it a bit better now?
It's better. Yes, we can hear you now.
So actually, I find that it took me some time actually to be able to deal with this a little bit better. And this is the challenge I face. It's not about being able to communicate what we do with the others, or it is sometimes that, this kind of perception that I think they feel that we are better at that because we pay attention to the detail, or they feel that they are very important and they don't want to deal with that. So this is the challenge I have.
And it might be a mixture of different things. Professor Mahendrawathi, did you want to come in on that question?
Yes, I mean, I think Maria put it very, very accurately. I think, yes, the question is not about what we work on, but how we can manage. I mean, being a woman, sometimes you also have other obligations that you need to do, not just with your work, but at work. Sometimes there's this stereotype that I mean, admin work is more of a women job, and then that takes a lot of our time to do. And because sometimes we are not so good in saying no, then everything keeps coming back at us. Being too good is also sometimes not so good for us. So yes, I found that too, which is a double-edged sword. I think it is true that we are more detailed, and we are more empathical. I mean, sometimes when we approach things, we look at everything from many different sides. I know, I'm sorry, I didn't mean to be sexist, because I can see that there are some men also in this meeting, but I do feel that way. And it takes a lot of courage just to say that, look, this has to be split equally, the admin work, and my job is in this area, and your job is also you need to take care of some of the administrative work too. So yes, I think that's why I'm smiling to hear you say. And for me, it's also a testament that it's not about culture, it's not about nationality. It happens everywhere. So I think it's a challenge for all of us, I think. Thank you.
Thank you. And just to respond to that and bring it back as well to events like this, I think it's why often when we speak to young women, we say one of the things that is very important is to network, and that network might be technical networks, but it also would be supportive networks as well, so that we can share experiences and help people to understand it's it's not about you, it's about everybody else, or everybody else who's dealing with you. And I think the issues around differences between gender, it's something that we should celebrate. We all have different personality traits and characteristics and skills. And in general, we can say that there are differences for sure. We know, we've seen this from scientific studies. And I don't think it's sexist for us to acknowledge that. We're certainly not saying that people are one type of person is better than other. We're saying we need to acknowledge that we're all good at lots of different things. So no, it's really, really good point. I'll stop now in case anybody else has any other questions.
We haven't had any additional questions, although Mansour Yousefi has added into the chat that he's had no issue working with female colleagues at all and has had many constructives in his academic life. So we have an ally on the call who's speaking to the his positive experiences of working with female engineers. So thank you, Mansour. And I know that Elaine and Christina and Maria will know Professor Yousefi as well. So Dr. Yousefi.
Yeah, we do. We work very closely. And I think the point that you were making there, Denise, about allies is really important. Again, going to what Maria was saying about different tasks sometimes being distributed. Often we find that the task of championing gender diversity falls to women much more than men. So we definitely need the male allies and people like our colleague Mansour, who is a great male ally. And encourages. So if a female student comes to him for advice and mentoring, he doesn't automatically say, go and see one of the women, because this is something that a lot of men do because they might feel a bit uncomfortable. And it goes back to one of the panelists talking about having a mentor that can be a man as well. It's really important. We don't have to have same gender mentors. It's really, really important that we encourage each other to network in this way. Professor Mahendra Wathi, I can see you've raised your hand.
Yeah. I just want to give a balanced view as well. I mean, at some point, sometimes we get this task, but also I have a lot of male colleagues that realize some of the challenges that women do and becomes our ally. What I found challenging is that there is no rules that really, I mean, at least in my country, what I found is that sometimes it's not really acknowledged that we face difficulties in for example, taking care of our families, for example. So we don't have this ability to manage between the time that we will put at work and also at home. And then some of the male has to cover for us because there are no rules for that. I think I just want to add that.
Similar with what Elaine said, that females are usually the advocates for EDI issues. Same with mental health. It's usually pushed towards the female side, although I found many of our colleagues in engineering that they are fully capable of doing it, and they are very empathic, and they are offering support to colleagues, females, and they I think in UK in the past 20 years, as well, the dynamic of the family changed. So more male, they are more involved in childcare, and we see this role swapping very easily, and they face similar issues like ourselves. It's just, I would say, in my case, I traveled from Romania with a child and I've been alone. So I totally relate to what you were talking about. Just be open about it and get your support bubble as big as possible. Yeah.
That's true.
I believe Dr. Yati, you have your hand up. Would you like to add to that?
Yes, can I add something? Just the science and engineering, since we talk about gender, it is genderless. It is open to both male and female. So anybody, I think Dr. Narumon mentioned, you do what you want to do. So It's genderless, so it is a field of study or a field of research that is open for everyone to take up. And then obviously for women engineer, because we will lead two kind of lives. One is personal and the other one is professional life. So obviously, huge bubble of support is very important for us to prosper within the engineering work, within the professional life. But what I always tell my students is for them to really, take any opportunity that comes by, because opportunity does not come twice in their life. Should the students have the opportunity to explore engineering work or attachment or mobility programs, get to know mentors, be it male or female, just go for it. Just go for it. And then, of course, being a female engineer is not easy. For example, I have a very petite size in terms of physical. So whenever I go to site, I may be judged based on my size and appearance as to would I be able, for example, to take care of a 5-liter wastewater sample, things like that. So there are things, small things that becomes your daily challenges in terms of carrying out engineering works. So I believe in everywhere in the world, women engineers are facing the same challenges. It can be something else here and there, but there's no stopping in terms of how might we prosper ourselves in, maturing and growing in the engineering field. Thank you.
Thank you. Thank you, everybody. So looking at the time, we are coming to the end. Do we have time to take a comment from Dr. May, Denise?
Feels a shame to interrupt this discussion. I mean, if people are still here and they're still paying attention, I've got nowhere to be. So please go ahead, Dr. Al-Safa.
I'm not going to take long. I just want to support and double my colleagues about that. Sometimes we misjudge and sometimes we get overwhelmed because of all the things that they put in our heads because they think that we can. So whenever you show that you are multitasker, you show that you are able to do, it's part of our challenging ourselves. But at the same time, other people will take advantages of it and they will put more work on you. So I end up like sometimes doing all the job, although my male colleagues, like they are able to do it, but yet since that you can, go to the side. So this is the thing that we are proud to do it, but at the same time, like, we need some sympathy. We need some like sensitivity, but all is good. Yeah, thank you.
The art of delegation, I think our male colleagues master it better than we do. Yeah.
Yeah, although I have very good, like my best relationship at work is always with male colleagues. Like we work very well together. Sometimes I feel like this pressure, like, I don't know, maybe it's indirect pressure or something, I don't know, but I'm fine, I'm okay.
I can fully relate to that. I can't say no, I have a problem. I need to we should have a course for being capable to say no. Yeah.
Oh yeah, this was an advice of one of my colleagues. Actually, she's my supervisor, Professor Anisa. She just told me when I start chairing the department, she said, May, try to learn how to say no. I'm like, I can't. Since I can't do it, why don't I do it? So I end up like, even like in my academic life, I feel that there is a lot. I'm happy that they are depending on me, but yet at the same time, like, where is my personal life? Where is my other life? But
we should have a course next year about how to say no and the art of delegation. Yes.
I think it's just been really wonderful and interesting hearing about the technical work, but all the different perspectives as well. And as Denise said at the start, this is that we've got some wonderful networks here with our universities. So this is hopefully maybe a starting point for us to form our own conversations and work together. And I'm now going to hand back over to Denise for finishing off our webinar today. Thank you.
Thank you all.
Thank you so much, Elaine, and thank you to all of our speakers today. As I said at the beginning, you know, we put the call out for Women in Engineering Day across our networks, both the WTUN and ATUNet, hosted by our dear colleagues at UTM in Malaysia. I'm going to just share a slide just to close out and just put some where you can find more information about the WTUN. And it would be remiss of me not to just also point to the fact that we have our Congress, annual Congress at the WTUN every year. This year it's being hosted by TU Ilmenau, one of our members in Germany. It will be taking place in October. And many of our sessions will be hybrid, so even if you're not able to attend in person, please do make note. All of your institutions via the WTUN, I should say, have been invited to that. And I know UTM also mentioned the President's Forum as well. It really was just to say that via the World Technology Universities Network and also ATU, the International Women in Engineering Day was just one annual event that we can work on, but a core focus of the network is around equality, including gender equality. And being a technology focused network, we want to collaborate with our colleagues around the world to progress that. So really it was just to reiterate to say that hopefully this is the start of some conversations. It was interesting to see how many parallels there were in some of the work that's being done at the institutions that we have here today. So perhaps, you know, linking up with some of the work, you know, happening at ITS, maybe with the University of Bradford, indeed, you know, with the work in environmental management, etc. So if there are any colleagues on the call that are listening and are interested to find out more about the work that the women on the call today we're talking about, you can always contact me at wtun@bradford.ac.uk. But yeah, I would like to formally bring that session to a close. If I may, before our speakers leave the call, I would love to just stop sharing my screen and maybe just get a quick gallery view of you all, so I can take a photo of you all here. But I'll give you a moment to prepare, and then I'll just print my screen. Wonderful, thank you all, and that's bringing the session to a close. Thank you.
Thank you, Denise.
Very much.
Thank you all.
Thank you.
Thank you.
Thank you, everyone.
Bye.
Thank you.
Bye.
Goodbye.